Okay, last one for this unit is factoring special product cases, so 2.7. So we are going to recognize and factor special product forms. So the first one we're going to talk about is one of my favorites, difference of two squares, or sometimes we just call it dots. It's a dots problem. Okay, so if you can recognize that you have a binomial, remember a binomial has two terms. So in our example here, a squared minus b squared is a binomial, and both terms are perfect squares. Remember how we filled out that giant table full of perfect squares? And you are finding the difference, which means subtraction, right? Then we can use a quick pattern to find the factored form, and our factoring form will be finding the square root of the first term and the square root of the second term. And then we're going to have one parentheses with a plus in it and one with a minus. Something to really remember when we're doing this is that the square root of x squared is x. Okay? So let's factor each of these polynomials. Number one, x squared minus 25. First check, is this a binomial? Yes. Are both terms perfect squares? Okay, x squared is always a perfect square. I'm going to actually write that down here. X squared is always a perfect square. Okay. Is 25 a perfect square? Can I multiply something by itself to get 25? Yes, you can multiply 5 by 5 to get 25, so it is a perfect square. Are we subtracting? Yes. So this is a dots problem. So my method to factor this is first take the square root of the first term. Square root of x squared, we already know, is x. Take the square root of the second term. Square root of 25 is 5. Then I jump straight to my answer. Remember, when you factor something, you have two sets of parentheses. With a dots problem, one is plus, one is minus. And then we just fill in the blanks. We have an x in both of them and a 5 in both of them. And that's it. That's our final answer. Okay. Let's look at number 2. First, do we have a binomial? Yes. Are both of them perfect squares? So our first term is 4z squared. Well, z squared is a perfect square. Any variable squared is a perfect square. Is 4 a perfect square though? Yes, 2 times 2 is 4. So that first term is a perfect square. At the other end, 1, is 1 a perfect square? Yeah, 1 times 1 is 1. 1 is a perfect square. It's a weird one, but it is a perfect square. Okay. Are we subtracting? Yes. So my method, we take the square root of 4z squared. Okay, well, the square root of 4 is 2. The square root of z squared is z. And then we take the square root of 1, which is 1. I jump straight to my answer. I have 2z plus 1 and 2z minus 1. So z. And that's my final answer. Okay, let's do number 3. Binomial, subtraction, both of them are perfect squares. So take the square root of x squared, that's x. The square root of 36 is 6. So my answer, we have x plus 6 and x minus 6. And that's our final answer. See if you can pause the video and do 4 and 5, and then come back and check your answers. Okay. Okay, I did number 4. I didn't narrate it, so I'm going to go through it really quick. The first term we take the square root is 10. Second term we take the square root is m. But this one's written backwards of what we've done on the other problems, right? Our variable is the second term. It matters which one goes where. So our first term always gets listed first in our parentheses. Our second term gets listed second. So that's why I have 10 plus m and 10 minus m instead of m plus 10 and m minus 10, because that one was written backwards there. Okay. Let's look at number 5. Take the square root of the first and the second terms. So your answer, 3n plus 4, 3n minus 4. Okay. Number 6 it looks a lot different, right? We have variables on both terms, we have numbers on both terms. It's the exact same process though, as long as our conditions are still the same. We're still subtracting, we still have a binomial, and we still have perfect squares because h squared and g squared are both perfect squares. 16 and 49 are also both perfect squares. So I want to take the square root of 16h squared and the square root of 49g squared. Well, the square root of 16 is 4, and then the square root of h squared is h. Square root of 49 is 7. Square root of g squared is g. So my answer, we have 4h plus 7g and 4h minus 7g. And that's our final answer. Same process, it just looks a lot crazier because there's a whole lot of variables going on there. So like I said, dots is one of my favorite problems because it's so easy to factor. So keep an eye out for that kind of pattern. Okay? The second type of pattern we look for is called a perfect square trinomial. Okay? So if we have a trinomial, remember a trinomial has 3 parts, and the first and the last terms are perfect squares. So the beginning and the end are perfect squares. We want to check the middle to see if it fits the pattern 2AB. If it does, then we have another pattern we can use. We find the square root of the first term and the square root of the second term, just like before. But the difference here now is whatever sign is in front of that middle piece is the sign that goes in our parentheses. So you can see up above in that square, they kind of got shifted, so it's moved over a little bit. But the plus is in front of 2AB. The plus is in my parentheses. Minus is in front of 2AB. Minus is in my parentheses. Okay. So let's practice a couple. Our number 7, we have n squared plus 8n plus 16. So first we check trinomial. We do have a trinomial. Second, we check for perfect squares at the beginning and the end. So n squared is a perfect square, and 16 is a perfect square. Okay? So to check for that middle piece, is that middle piece 2AB? Let's first find out what a and b are. And this a and b is different than the a and b in our trinomial. A and b refers to what's the square root of n squared and what's the square root of 16. Well, square root of n squared is n, square root of 16 is 4. So if I times 2 by 4 and n, will I get 8n? Yeah. 2 times 4 times n is 8n. So that works. Okay. So now I can jump to my answer. Oh, maybe if my iPad doesn't freak out on me here. Hey, so my parentheses, remember we have 2 of them. We have n and 4 in both. Okay. Now to place the signs in, I want to look at what sign is in front of 8n. It's a plus, so plus goes in both. You can circle that as your answer, or you could write it like this. Those mean the exact same thing. Okay. Let's look at number 8. We have a trinomial. Let's check our perfect squares. Yes, that first one is a perfect square and 9 is a perfect square. We need to check the middle piece now. So take the square root of 4x squared and the square root of 9. The square root of 4x squared is 2x. The square root of 9 is 3. So, whoa. Geez, my sleeve is moving my screen. We have to check is 2 times 3 times 2x. Does that equal 12x? Okay. Well, 2 times 3 is 6, times 2 is 12x. That works. So now I can write my parentheses. I have 2x and 3. What sign goes in there? Well, 12x is negative. So we put minus in both of them. Whoops. We could leave that as our answer, or we could write it as 2x minus 3 squared. Okay. Try number 9 on your own, and then come back and we'll do it together. So we have a trinomial. We have a perfect square in the front and the back. So I'm going to take the square root of both and check 2 times 1 times m is 2m. That's the middle part, so we are good to go. I jump straight down to my answer now. We have m and 1, m and 1. What sign goes in there? Well, 2m is negative, so those are both negative. So my final answer, m minus 1 squared. And now number 10, almost done. We have a trinomial. We have a perfect square in the front and the back. Let's take the square root of both to check the middle. 9z squared, the square root is 3z. Square root of 36 is 6. So I want to say 2 times 6 times 3z. I should get 36z. And I do. If I multiply 2 times 6 times 3, I get 36z. So we're good to go there. Jump straight to my answer. I have 3z and 6, 3z and 6. 36z is positive, so both of these are positive. So my final answer, 3z plus 6 squared. Okay, last one we have a word problem. So number 11 says a bird picks up a golf ball and drops it while flying. The function represents the height y in feet of the golf ball t seconds after it is dropped. The function they're talking about is actually underneath the bird here. That's the equation we have. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit the tree? Okay, so what's important here? Okay, well, we have the function. I've underlined it under our bird there. Okay, it says that the ball hits the top of a 32-foot tall pine tree. I think that's pretty important, how tall the pine tree is. And what is it asking us to find? Always find. What is it asking you to figure out? It's asking us to find after how many seconds does the ball hit the tree. So we're looking for t. We don't know what t is, but we want to figure out what it is. Okay, I'm going to write down my equation. Y equals 81 minus 16 t squared. Okay. They actually tell us why. We don't know what t is, that's what we're trying to find, but they did tell us why. They told us that we're hitting a 32-foot tall tree. That's why. So I'm going to replace y. Whoops, I did not mean to write equals there. Minus. Okay. So in order to figure out what t is, I want one side of this to equal 0. That's how I can solve for my variable, is by setting this equal to 0. So I need to subtract 32 from both sides. I'm going to make that side equal 0. So I end up with 0 equals 49 minus 16 t squared, because 81 minus 32 is 49. Okay. But if you look at the right side of our equation now, 49 minus 16t squared, that is a lot like our dot problem from before, the dots, difference of two squares. Okay. So I am going to factor this. I know how to factor this really easily, right? Take the square root of the first and the square root of the second. We get 4t and 7. So I'm going to rewrite this instead as 49 minus 16t squared as 7 plus 4t and 7 minus 4t. Okay. Now we're going to backtrack to the first unit of this, the first section of this unit, where you learned about the zero product property. If I have two things that are multiplied to get 0, that means that one of them has to be equal to 0. So 7 plus 4t would equal 0, or 7 minus 4t equals 0. But now I have two equations that I can solve for t. I've kind of run out of room. So I'm going to move over to the side here. I have 7 plus 4t equals 0, or 7 minus 4t equals 0. Okay, I'm going to do the left one first. We want t by itself, so I'm going to subtract 7 from both sides, and then divide by 4. So t would equal negative 7 over 4. I'm going to do the other one now. Subtract 7 from both sides because I want t by itself. Divide by negative 4 this time. And we get t equals positive 7 over 4 because it's negative over a negative. Okay. Only one of these answers makes sense for our problem. We're talking about time, how many seconds. So we have a negative time and we have a positive time here. Time is not negative, that means we're going back in time. So we're not going back in time here. We want a positive answer when we're talking about time. So my final answer is t equals 7 over 4 seconds. That's how long it takes for the golf ball to hit the tree, which is really fast. Okay. So the next part, it says, what if the golf ball does not hit the pine tree? What if it hits the ground instead? After how many seconds will it hit the ground? Okay. So instead of saying that y is 32, if we're hitting the ground, that means that our y is 0. So I'm going to take my original equation again, 81 minus 16t squared, and instead of setting it equal to 32 or y, I'm just going to set that immediately equal to 0. On the right side, I have another dots equation. I can factor this. Jeez, I don't know what is going on. I'm getting all those weird lines popping up. Okay, to factor this, remember you take the square root of the first, the square root of the second. So I have 9 plus 4t and 9 minus 4t. Here's that zero product property again. If I have two things multiplied equal to 0, that means that either 9 plus 4t equals 0 or 9 minus 4t equals 0. We're going to solve both of them. Subtract 9 from both sides. Divide by 4. Same on our other side. Subtract 9 from both sides. Divide by -4. So the first one we get -9/4, and then we get +9/4. Remember, time is not negative. I don't want this answer, just like I did not want -7/4. So my answer is 9/4 seconds. So it takes a little bit longer to hit the ground, which makes sense, right? If it's going past the tree, it's not hitting the tree anymore, it's hitting the ground, it should take longer to get there. So this makes sense. So those are our two special patterns we're looking for, dots and perfect